All right, Algebra 1. These are your 2-2C notes, and what we are doing here are the factoring difference of two squares. So basically, let's go back and review what we did in the 2-2A notes. This is not a mistake. We did not miss 2-2B. We skipped over them. That's a concept that we are not going to cover this year. So we're not going to cover the 2-2B notes. So anyway, 2-2C notes. So let's go over the factoring of GCF. So basically, look at your numbers, 6, 12, and 8. What is the biggest number we can take out of all of them? And that is a 2. So we know we're going to take a 2 out. And then we look at the x's. We want the smallest power of x. So we got a 3, 2, and a 5. Smallest power there is a 2. And then we look at the y's. Smallest power for y, we have a 5, 3, and this is, remember, this is a 1 if nothing is written here. So the smallest power for y is a 1. Also, if we notice here, we have a z squared, but since these other terms are missing a z, we will not have a z as part of our GCF. So we take 2x squared y is the GCF, but then remember from 2-2a, what we finished out was we actually took that and divided it from each term. So 6 divided by 2 was 3. And then x to the third, if we took out x squared, we were left with an x to the first. Y to the fifth, took out y, we were left with y to the fourth. Minus 12 divided by 2 is 6. We started with x squared, but we took an x squared out. So there's no x's left. And then we started with y to the third, and we took a y out, we're left with y squared. Next, we started with an 8 divided by 2, gave you 4. And x to the fifth divided by x squared gave you x to the third. Started with a y, but we took that y out, so there's no y's. And then we started with z squared, but we didn't take any z's out, so we're left with z squared. All right, so that's your final answer there for the bell ringer. All right, now, so the new stuff for today, this is the difference of two squares, which we will also refer to this as dots, just abbreviating that, D-O-T-S, difference of two squares, dots. And basically, we're only dealing with real numbers, so to say any real numbers is kind of arbitrary. We don't really need to say that because we're only dealing with real numbers in Algebra 1. But anyway, if we have real numbers, a squared, which this will typically be a variable, the first term. Sometimes the variable can be second, but usually it's first. A squared minus b squared, this is kind of our template. This is what we're going to fill our numbers into, a plus b and a minus b. But the main thing I want to point out to you here is that when we do this factoring, they will look identical, so the first terms will be the same, right? The first terms will be the same, and your second terms will be the same, right? They're the same number or the same variable. The only difference here is one will be a plus and one will be a minus, okay? So that's the only difference in those two sets of parentheses. Now, what we need to remember here, and I have this listed, what's important, is that if we have a squared plus b squared, this does not factor, and we will write prime, just like if we have the number like 7 doesn't factor. There's no factors of 7 other than 1 and 7, that's prime, and we will write that this is prime, this does not factor. Okay? Now, before we jump into some examples, what we need to do is we need to be able to easily identify what our squares are, okay, what our perfect squares are. So what we're going to do is make a list. So if you look at your notes, what I had on your notes, I had a list that started out with 1, 4, 9, and then comma, and then a bunch of blanks, comma, blank, comma, blank, comma, blank. We're going to fill all those in. Okay, so what those are the perfect squares. So it was 1 squared is 1, 2 squared is 4, 3 squared is 3. So we're going to fill in the rest of those. Okay, so what we have here, this is 4 squared is 16, 5 squared is 25, and then 6 squared is 36, 7 squared is 49, 8 squared is 64. Feel free to pause this and write these down if you want, and then, play it if you want. You can pause and play or whatever. 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and then 15 squared is 225, and we could go on and on and on and on and on, but I doubt you'll see any numbers any larger than that. Those are the ones that you should be able to easily recognize, and I would say probably up to 12, 144, you probably already recognize those numbers. So really we're just adding in three numbers that you might not already recognize, okay? Because I'm sure up in like third grade you did up to 12, your 12 by 12 times tables, so you probably already recognize up to 144. So we're just adding three extra ones. All right, so now we're ready to start some examples. I did not fill in any of these examples for you. I want to go over all of these with you. So feel free to pause, rewind, and play the video at any point in time during this, just to make sure. So what you want to do is you want to ask yourself three questions, okay? And, they basically go along with the dots, difference of two squares. It's basically they're right there in the difference of two squares. The first question is right here. It goes with the first term with the difference. So the first one goes with the D for difference. You want to ask yourself, is this a difference? Okay, is this a difference? So yes, this is a difference. It's a subtraction. So yes, it is a difference. Next, do we have two terms? Because if it's not two terms, then it's not the difference of two squares. So yes, there are two terms. We have the x squared and we have the 100. And then the second part is, are they both perfect squares? So x squared is a perfect square. Now, when you have a term being squared, the way that you know it's a perfect square is if it has an even power. So, like x squared is a perfect square, x to the fourth is a perfect square, x to the sixth, x to the eighth, x to the 10th. You can go on and on and on. Anytime you have a variable to an even power, that's a perfect square. Okay? The number is when you need to think about this list for your perfect squares. So 100 is a perfect square, so it will work. So what we need to do is we need to set up our template. So two sets of parentheses like this. And we say, what times itself? How do we get x squared? Well, that comes from x times x. How do we get 100? Well, there's a lot of different ways that we can get 100, but it has to be some number times itself. That comes from 10 times 10, okay? Remember, they have to match. These numbers have to match. So x and x, they have to match. 10 and 10, they have to match. You can get 100 from, 5 times 20, 4 times 25, whatever. They have to match. So 10 times 10. One's a plus, one's a minus. That is it. That is all we're doing right there. What you see right there, that's it. All right, next, x squared minus 49. Let's ask ourselves the three questions. Is it a difference? Yes, we are subtracting. Do I have two terms? Yes. Are they both perfect squares? Yes, I have an even power, and 49 is a perfect square. That's 7 times 7. So now I'm ready for my two sets of parentheses. And I say, what times itself gives me x squared? That's an x times an x. What times itself gives you 49? That's 7 times 7. One's a plus and one's a minus. Now, we can mix it up. We can put the plus sign over here and the minus sign over here. That doesn't matter, okay? The plus sign and the minus sign can go wherever. It's just one has to be a plus and one has to be a minus, okay? So we can have x plus 7 here and x minus 7 here. That doesn't make a difference, okay? It's just one has to be at one spot and one has to be at the other spot. Next, ask yourself the three questions. Is it a difference? No, this is a plus. So this is not the difference of two squares. This does not factor, so we're going to write prime. Okay? Next, 16x squared minus 9. First of all, is it a difference? Yes. Do I have two terms? Yes. Now, when we do our third part here, are they both perfect squares? Is 16 a perfect square? Yes. X squared is a perfect square, and 9 is a perfect square. Now, this one's a little bit tricky, but it's not any different. It's still the same process. The only difference here is our first term, instead of it just being an x, we have to have some more stuff because we have a 16. It's not just x squared, it's 16x squared. So what times itself gives you 16? Well, that's a 4. What times itself gives you x squared? That's an x. So the 4x will be your first term now instead of just an x. Okay, so that's where it's a little bit different. 9 is 3 times 3. One's a plus, one's a minus. All right, and there we're done. And again, just like we did last week, the important part about doing this stuff last week is we can multiply this out, and we should get our answer up here. So we could do 4x times 4x, 4x times negative 3, 3 times 4x, 3 times 3. You know, you can multiply that all out and see if you get what you started with. Next. All right, now look, right here, x to the 8th. First of all, is it a difference? Yes. Do we have two terms? Yes. Are they both perfect squares? Yes. Anytime we have a variable to an even power, that's a perfect square. Okay, so even though 8 is not a perfect square, if we have a variable to an even power, that's a perfect square. 121 is a perfect square. All right, so let's make up our two sets of parentheses here. 1, 2. So what times itself gives you x to the 8th? And that's going to be x to the 4th, because remember we would add those exponents. 4 plus 4 gives you 8. What times itself gives you 121? That's 11. 1's a plus. I'm going to mix them up again here. 1's a plus. 1's a minus. Final answer. Okay? So again, just because it has a power of 8, it doesn't mean that it's not a perfect square. For variables, you just need to have an even power. All right? One more. I think this is the last one right here. Yep, one more. Okay. Is it a difference? Yes, we have a minus. Do I have two terms? Yes. 1, 4x squared, 169, we have two terms. Are they both perfect squares? 4 is a perfect square. X is to an even power. That's a perfect square. And 169 is a perfect square, so I'm ready for my two sets of parentheses. What times itself gives you 4? Again, it has to be times itself, not 1 times 4, times itself. So 2 times 2. X to the 6th. Remember, we have to split that up so it's even, so they're the same, okay? So they have to be the same power. So that means it has to be x to the 3rd and x to the 3rd, okay? So they have to be the same. And then again, for 169, it has to be what number times itself. So 13 times 13. 1 plus, 1 minus, and there is your final answer. Okay? So again, if you have any questions on this, rewind the video, watch those examples again, and if you're still unsure about something, just let me know, and I'll try my best to help you, or you can ask in class or anything. Send me a private comment, send me an email, and just let me know if you have any questions on this.